before we get into trig graphs with a vertical shift, I want to go ahead and just review real quick, what does a vertical shift look like in a graph? If I asked you for y equals, say, x squared, you would know that it's centered at the origin and it moves upward. And if I was to say y equals x squared plus 1, you would know that it's shifted up 1. And that's it, right? Well, vertical shifts in trig graphs are no different. If I say y equals sine of x, you should know by now that that graph looks like this, where it ends at 2 pi, halfway between is pi, pi over 2, and 3 pi over 2. So if I asked you for y equals sine of x plus 1, oops, I'm sorry, made a mistake there. My upper bound is 1, my lower bound is negative 1, and I forgot the 0. What you should know is that now you're shifting everything up 1. So what I'm doing is I'm going to go ahead and draw a new x-axis of sorts where my center is at 1. Now, because sine has an amplitude of 1, which you should have learned from the last video, we now know that the upper bound is going to be 2 and the lower bound is going to be 0. And so your graph will look like this, where this is now pi, 2 pi, 3 pi over 2, and pi over 2. All right, that's how vertical shifts work. And so we will do a few more examples of this. Let's take a look at number 2 here. If I say y equals cosine of x and then minus 3, I'm asking you to take a regular cosine graph and shift it down 3 points. So if we look at a normal cosine graph, which is centered at 0 and has an upper bound of 1 and a lower bound of negative 1, it usually does this, right? But now what we're going to do is we're actually going to shift everything down 3 units. So down at negative 3. And so now, because cosine starts at its maximum point, everything's going to be shifted down 3. So it used to be centered here at 1. So 1 minus 3 is now going to give me negative 2. And then my lower bound here is going to be negative 4. So from here, the graph simply looks like this. And it ends at 2 pi, pi, and then pi over 2, and then 3 pi over 2. All right, remember, cosine always starts 1 above what the center line was. Next example, if I say y equals tangent of x plus 2. I'm going to shift everything up 2. And then with tangent, remember I draw in my points first, so pi over 2, pi, 3 pi over 2, and 2 pi. My asymptotes are going to occur at pi over 2 and at 3 pi over 2. And then from here at 2, not at 0, at 2, I'm going to have this motion here. So vertical shifts aren't really that hard. So let's do a cosecant. Y equals cosecant x plus 1. So I'm going to go ahead and just draw a sine first. And remember, the sine is going to be up 1. So that's 1, which means that now it's going to have a maximum point of 2 and a minimum point of 0. Sine is going to behave like this at 2 pi, at pi, and then pi over 2, and at 3 pi over 2. Now, where this thing has asymptotes is where it equals 0. So where it crosses your new imaginary x-axis is going to be where you have your asymptotes. So here at pi, and at 2 pi. And now from here, we just reciprocate everything. All right. And I think you can figure out the rest from there. Vertical shifts aren't that hard. We'll see you in the next one when we talk about period change.